All right, today what we're going to look at is section 8G, it's called Communications and Connections. What you're looking at here is you're going to be given a diagram of how people or towns or other things are connected, and you're going to create a matrix, and then you're going to be able to do some manipulations and answer some questions based on those. For example, if you have 6 people who know each other, but they know some of the people in the group, but not everybody in the group, we can make a matrix to determine how many people know how many other people in the group, and then we can square it to find out how many people have two-way connections. For example, let's say that you're sitting next to somebody that you do not know, but you do know the person next to them. So you know that, and they know the other person, so you have a two-way connection to them. Your friend knows them, therefore there's two directions of travel there. There's 2 people to get to knowing them. So we're going to look at these. Okay, so what we're going to do is we're going to talk about the process, and then we're going to look at some examples, and we'll go through how this works. It's incredibly easy. The first thing is you're going to have a diagram, and we've looked at those before. So like you have A, B, C, and D, and A is connected to C and D. Do you remember these? And we've drawn matrices from these before. And D and B are connected, that kind of thing. So you're going to have those diagrams demonstrating a series of connections, all right? And so what your first job is to simply build a matrix from the diagram. So you're just going to build a matrix using A, B, C, D as the titles for the rows, and A, B, C, D as the titles for the columns as well, right? Because we're going to see how these things are connected to each other. Remember we did this before, and what do you always know about that diagonal of connections? It's always going to be a row of, it's going to be a diagonal of zeros because you can't connect to yourself, right? So you're going to have that same diagonal of zeros. And because we're talking about connections, and those connections are going both ways here, you're always going to see that every row in every diagonal are going to be the same. So these things are totally symmetrical. And again, we'll talk about what that means. And that gives it some properties. If you were to go on and explore it some more, you would see that it gives it some specific properties, but we're not going to go there. And they're also always a square matrix. And that's because you have the same number of rows as columns, because that you got the information from a diagram where we were talking about using the same rows and columns, which also gives it some properties, right? First of all, you know that you could multiply one of these times another one if you're getting the same information or different information about the same group of people, etc. All right. Second, okay, they will always be symmetrical. And again, the reason they're symmetrical is because you're getting the same information from the diagram. So if you're connected to someone, then that person is connected to you, right? So you're going to get symmetry across these. And again, that may not seem important, but they're going to ask you some questions about it. So third, the sum of a row or column, because again, these things are symmetrical. It doesn't matter which one. The sum of a row or column will always tell you, gives the number of connections. So if you add it up and find 3, that means that person in that row knew 3 of the people in the group, for example. Okay? 3 direct connections. And finally, the last bit of math that we're going to do on it anyway is squaring the matrix. Remember that squaring a matrix means to multiply it times itself. So squaring the matrix will give the number of two-way connections. For example, you may be taking a train. There's a train that goes directly from Brisbane to Sydney, but not one that goes directly from Brisbane to Melbourne. But you may be able to take a train from Brisbane to Sydney to Melbourne. So that's a two-way connection, right? And so squaring the matrix will tell you how many of those two-way connections you can make. Right? So that one, the connections like between towns or something actually does have a little bit of a real-world application where you're looking for the shortest possible route to someplace, perhaps. Okay? Other than that, very few real-world connections here. So what we're going to do is just go through and look at the book and look at their example. They're not even going to show you all of the multiplication or the squaring because we've done that, but when we do the examples in the homework, we will go through some of those for you, just to remind you of what it looks like. But they are going to give you a series of questions that you can answer, and so we'll talk about those and look at the kind of information that you can get from one of these matrices. Okay, so first of all, we're given a diagram with showing the connections between a group of people. And notice that one couple of things about the diagram. First of all, the arrows are double-headed. That means that the communication goes between both of them. So Vicky communicates with Stephen, and Stephen communicates with Vicky. That that double-headed arrow indicates that the communication goes both ways, and that's one of the reasons why these will always be symmetrical. Okay. If there is no arrow directly connecting people, then they have no connection. For example, Vicky and Paul clearly don't know each other in this particular diagram. Okay. And they're called one-step connection because there's just one direct link from person to person. Okay? So we're going from Vicky to Kathy straight away, one to the other. All right. But from this, we can create a matrix. And then we can answer some of these questions about how these pieces go together. So you can see here they've drawn the matrix, and again, as we talked about, you can see that the diagonal here is all zeros because Vicky can't lead to Vicky. There is no line leading from Vicky to Vicky if you're already at one spot, right? Then all of the other connections you can see are symmetrical along that. And again, that's because of the way the connections go. So one line away is all ones, 2 lines away is all ones, 3 lines away, all zeros. Okay? We're going to talk a little bit about what that means and what that does to the matrix. So let's see what questions they ask you. So it says, explain why there is symmetry about the leading diagonal of the matrix. So in other words, it's not just the diagonal this time, which is all zeros, but the entire thing. And that's because each person, the communication goes both ways. So, for example, if there's one connection from Vicky to Stephen, it's also connected Stephen to Vicky, right? So you're going to get the same number of connections above that diagonal of zeros as well as below. They're not always going to be ones, right? You could have different connections, different numbers of them, but it's always going to be symmetrical. Okay? Again. Now, what information is given by the sum of a column or row? We talked about that in the notes. If you take the sum of a column or row, it doesn't make any difference. Then it's going to tell you the number of connections that there are. Yeah, exactly. And then if you square the matrix, take the whole matrix and multiply it times itself, it's going to give you the number of two-step communications between people. So for example, if you look at D here that they've given you, Vicky to Vicky now has 2 connections. And what that means is that Vicky can contact herself or communicate with herself through other people. For example, you might ask somebody to remind you about something, to call you and remind you about something, right? So you've asked them to contact you. So that's what a two-way communication looks like between yourself Or if you see that Stephen has 3 connections, so between someone else, so you could call someone and ask them to call Stephen, that kind of idea, right? So that's what a two-way connection looks like. Okay? And you can find, in order to find those connections, you need to go back to the diagram and think about how those connections would be made. Okay? The matrix can only tell you how many there are, but you have to go back to the diagram to talk about, to be able to list them out. Okay? So that's the kind of thing that we'll be doing. And then if you cubed it, you'd get the 3-step communications, and that might be a little bit of an extension thing that's quite possible for you to see. So let's just go to the homework, and we'll talk about some of these.